Please be seated.
Hereby I open this academic ceremony at Maastricht University. My name is Ton de Goey. I am the pro-rector of the ceremony and chair of the degree committee. First of all, I welcome Mr. Shengshi Huang, and he will defend in public his academic thesis, The Molecular Linkage of von Willebrand factor and Pathological Coagulation in Disease. Welcome all members of the degree committee, and in particular the three supervisors, Professor Hugo ten Kate. He is Professor of Internal Medicine, in particular thrombosis and hemostasis, at Maastricht University. Dr. Bas de Laat, he is Associate Professor and Director of Synapse Research Institute at Maastricht University. And Dr. Marisa Nini Bargi, Research Project Leader of Synapse Research Institute at Maastricht University. I will introduce the 5 opponents later during the ceremony and during the opposition. Welcome to the audience here in this small aula to Paranymphus. And I would like to invite you to present a summary of your thesis. And I wish you success in the coming hour. The floor is yours.
Thank you, Prorector. Dear Prorector, dear members coroner, dear colleagues, friends, and thank you for attending defense my PhD thesis, which entitled The Molecular Linkage of von Willebrand factor and Coagulation in Disease. VWF is an important glycoprotein in blood, and its central role in many processes, including hemostasis, inflammation, immune thrombosis, vascular permeability, and netosis and angiogenesis. VWF can take many different forms, such as globular form, linear form, ultra-large form. The differences of forms determine the activity of VWF. The ultra-large form is secreted from platelet and endothelium, rapidly cleaved by ADMTS13, and when the blood vessel is damaged, VWF can adhere to collagen and platelet to help with the formation of clotting. In order to measure coagulation, we can perform thrombin generation test. Thrombin is a central enzyme in the coagulation cascade. The thrombin generation test measures the formation of thrombin over time. The commonly used parameters including lag time, ETP, peak, time to peak, and velocity index. Lag time means the time point that the concentration of thrombin start to be detected, and ETP is the area and the curve of the thrombin generation, and TTP is time need to reach the peak of the curve. High thrombin generation is associated with thrombotic complications, and low thrombin generation is an indication for the bleeding tendency. In clinical application, thrombin generation assay can assess thrombosis and bleeding risk, monitor anticoagulant therapy, and evaluate treatment with antithrombotic drugs. Combining with the result of thrombin generation, we also calculate thrombin dynamics using computational model. And the parameters of thrombin dynamics consist total amount prothrombin conversion, maximum velocity of prothrombin conversion, thrombin activation by antithrombin and alpha-2 microglobulin. And the last one is thrombin decay capacity. In this thesis, we explored the functional changes in platelet and coagulation during asexual and sexual parasitemia in a controlled human malaria infection. We compared the levels of total VWF, active VWF, and VWF propeptide between people living with HIV that differed in their thrombotic risk due to differences in the treatment. We described the effects of the interaction between VWF and platelets in patients with antiphospholipid syndromes. And we also described the correlation of total VWF, active VWF, and VWF propeptide with LOC antibody to GP1 anti-coagulation in EPS patients. In chapter 2, we want to investigate homeostatic changes in human malaria infection. Malaria is the most important parasitic disease worldwide. In this chapter, using the methods of thrombin generation and thrombin dynamics, we try to assess changes in the number and function of platelet and relation with changes in total and active VWF and the coagulation system during infection and after curation in blood samples from participants that in a controlled human malaria infection. We found that the platelet numbers decrease during the stage of sexual parasitemia, and the ratio of MPV, mean platelet volume, and platelet count was significantly increased during this stage. The lag time and time to peak height showed a significant increase during sexual parasitemia, but with unchanged in the ETP. We also see the significant decrease in the total amount of prothrombin conversion, maximum velocity of prothrombin conversion, the concentration of thrombin, antithrombin, thrombin alpha-2 complex, also during the stage of sexual parasitemia, but with unchanged thrombin decay capacity. Yeah, this result indicated that in patients infected with malaria, platelets were activated, and there was a thrombotic tendency in the circulation, but thrombin generation didn't change. In chapter 3, we would like to investigate whether abacavir-based treatment affects prothrombin conversion and thrombin activation by applying thrombin dynamics analysis, and can provide an explanation for the higher thrombin generation potential compared to other therapy. The results show that the levels of total VWF, active VWF, and VWF propeptide didn't differ in HIV patients, whether or not received abacavir or non-abacavir treatment. The total amount per thrombin conversion, maximum velocity of per thrombin conversion, and antithrombin complex were significantly higher in people living with HIV on abacavir-based treatment compared to the other treatment. But we didn't show any difference in the levels of thrombin F2M and thrombin decay capacity. Chapter 4 is a systematic review focused on APS. The antiphospholipid syndrome is characterized by thrombosis and or pregnancy morbidity with the persistent presence of antiphospholipid antibodies. In this chapter, we would like to describe how VWF induces platelet adhesion, activation, and aggregation, as well as how APRS interact with platelet receptors. In chapter 5, we want to investigate whether high levels of active VWF is associated with thrombotic APS, non-APS thrombosis, and non-APS autoimmune diseases. The results show that the levels of total VWF, active VWF, and VWF propeptide were significantly higher in APS in the patients of APS thrombotic controls and autoimmune diseases controls compared to healthy individuals. As for the correlation between VWF and EPLS, only in patients with positive luck were observed higher active VWF levels. No significant difference was found in other groups. So, in conclusion, malaria induces acute activation of some endothelium, increasing VWF levels and activity and promoting platelet activity. However, no indication was observed for an increased procoagulant state. People living with HIV on an abacavir-containing regimen demonstrated increased thrombin generation. The activation of the endothelium, including VWF levels and activity, was not observed between patients treated with abacavir or those treated differently. And the activation of the endothelium was dramatically elevated in those who suffered thrombotic APS. Higher levels of active VWF can be used to identify thrombotic APS patients. For the future perspective, measuring VWF in all three variants can help establish the thrombotic bleeding risk in patients with different pathologies. Moreover, it can help stratify the patients that can benefit from anticoagulant treatment. Further research is needed to establish in which other diseases it may also be important to measure VWF and what type of antithrombotic treatment should be given to those patients if needed. Yeah, that's all my presentation. Thanks for your attention. Next, I give the floor to Project.
Thank you, Mr. Shengshi Huang, for this summary of your thesis. The opposition will be opened by the chair of the thesis assessment committee, Professor Erik Bekkers. He is Professor of Internal Medicine, in particular hematology, at Maastricht University. Professor Bekkers.
Thank you very much, Mr. Prorector. Dear candidates, I would like to congratulate you and your supervisors on your achievement, on your scientific work, which resulted in your PhD thesis. And you have contributed a lot to our knowledge on the physiological role of virulent factor in pathological conditions. So it's a physiological part and a pathological part. In other words, you have tried to describe how virulent factor behaves in different pathological conditions. And in your layman presentation, you gave us an overview of what you did. And I would like to focus and discuss with you some aspects of chapter 2. You showed us a figure, and I would like to discuss some other figures in chapter 2. So you have generated a lot of data using an elegant model, I didn't know this model, the model of controlled human malaria infections. And I would like to first go to figure 1 and page 37. And my first question is, could you, because you didn't mention it in your layman talk, could you, in your own words, explain to me what this figure, what in figure 1 is depicted?
Yeah, esteemed opponent, thanks for your kind words and thanks for your question. Yeah, the figure 1 is a platelet count and volume in 3 stages of Plasmodium falciparum infection. And figure 1a is the platelet count in these 3 stages, including the stage baseline, sexual parasitemia, and after curation is day 64. Yeah, in the figure 1a, we can see the platelet count was decreased during a sexual parasitemia, but it recovered to the normal platelet count when after the curation. And the figure B is mean platelet volume of every stage. Yeah, we can also say the mean platelet volume is a significant increase after the curation compared to the baseline. And the last one, figure 1C, is a ratio of between mean platelet volume and platelet count. This figure means the activity of platelet. Yeah, if this.
Can I ask you something more about the last? That's my point.
Yeah.
So I know what platelet count is, and I know the MPV.
Yeah.
That's what I'm used to look at.
Yeah.
I don't know this new variable which you put, the ratio MPV platelet count. And when I look at the figures, in my opinion, just by doing the math, if the denominator is lower, the ratio will increase. So that's what you see in the figure.
Yeah.
So the MPV platelet ratio is not further discussed in this chapter, but you mention it in chapter 7 in the general discussion, and you state that this ratio may be more clinically significant than platelet count or MPV alone. Now, as a clinician, I was triggered by this statement that it may be more clinically significant. What do you mean with clinically significant using this ratio?
Because this figure, this ratio of MPV and platelet reflect the platelet reactivity. Yeah. If we want to explore the coagulation, coagulant state of inner circulation, we need to find the reactivity whether or not the platelet activity is activated or not activated.
Do you mean by significant, possibly, I'm just imagining it, so it's just for clarifying reasons. Do you mean by significant, statistically significant, or really that it's useful in the clinic?
This is about clinic.
Okay. So it's relevant, in your opinion?
Yeah, relevant.
Okay. In your proposition number 4, would it be possible to read it out aloud? For one of the
So long you may read it aloud.
Proposition 4. Platelet activity increased after malaria infection as detected by flow cytometry and the circulation of the mean platelet volume divide platelet count, MPV divide TRT ratio.
Again, you think it's important that we use this ratio. Indeed, you state that platelet activity as detected by this ratio.
Yes.
And then I'm puzzled. So how can you explain that one? So what has this ratio to do with platelet activity?
We use this activity to measure to decide whether the release of alpha granules release or dense granule release, because after activity of platelet, the coagulant factors will release from alpha granules, and the contains like calcium and K will also release from it. So it's important for the coagulation cascade. So I think it's very important.
Okay. I was just because your title of your thesis on your research is relevant factor, and just a question about relevant factor and its impact of relevant factor in this disease. You have studied this model in malaria infection. Can you describe, because you explained it in the discussion, but can you explain again what happens during parasitemia with relevant factor, and why does it lead to lower platelet count or a decrease or increased ratio?
Yeah, I think after malaria infection, it first enters a state of asexual parasitemia. In this stage, parasitemia will hide in liver. And after enter the stage of gametocyte, the parasites will come out to the red blood cells, and in this stage, I think it will induce thrombocytopenia.
You mentioned endothelial activation
Endothelial.
as a mechanism. That
Yeah.
infection will lead to endothelial activation,
Yeah.
leading to more relevant factor, leading to thrombocytopenia. Is that correct?
I think malaria indeed induces endothelium activation.
Just one short question still.
Sure, yes.
Probably you will expand on it. Because, as you explained us, there are more forms of relevant factor. Relevant factor can derive from endothelial cells and also from platelet cells. What's your opinion on the influence or the contribution of these two, endothelial and platelet, in the rise of relevant factor malaria?
I think the larger of platelet volume, they will have more VWF, more high levels of VWF. I think so. If the higher volume of platelet, higher levels of VWF, and higher ratio of MPV and ratio of MPV and platelet count, higher level of VWF. That's correct.
Thank you for your answers. I'll hand over the floor back to the prorector.
Thank you very much, Professor Beckers. The next opponent is Professor Rory Koenen. He is Professor of Vascular Inflammation and Thrombosis at the Department of Biochemistry of Maastricht University. Professor Koenen.
Thank you, Mr. Prorector. Yes, dear candidate, I also wish to express my compliments and congratulations with this very nice thesis, and I've read it with interest. And before I start with my own questions, I want to first get something clear from the discussion with my previous, with the previous opponent. Is, do you mean that the platelets get smaller when they get activated, so that their contents are lower and the platelets shrink because of that? Is that the answer that is sort of hanging in between the lines, or did I misunderstand?
Dear esteemed opponent, thanks for your kind words and thanks for your question. Yes, I agree. I agree this point of view that if the platelets were activated, platelet volume will decrease, and then it will release the VWF. Yeah.
Okay.
I agree.
Then I want to draw your attention to figure 1b and 2 on page 37 of your printed thesis, where you can see, in my opinion, that in figure 2a and b there are signs of platelet activation, and this is actually not reflected that much by the changes in mean platelet volume you see in figure 1b. Can you explain a little bit this difference so that it's clear to me?
Yes. In the figure 1a, the platelet counts will show a significant decrease. Yeah, in the stage of sexual paracentemia. I think it's because we measure the platelet left after.
Okay.
Yeah.
Because that is what I wanted to ask because of your answer. So you think platelets that are really strongly activated are no longer visible in your facts analysis?
Yeah, that's my point.
Okay, good. Then I leave it like this. And then I move to the question I actually wanted to begin with, and that involves the differential equations of your thrombin dynamics that you also showed in your introduction. Sorry, not the discussion, the introduction. And I was sort of interested by these. I like mathematics, maybe you do so as well, and I was interested by these equations that you say, okay, the rate constants of the inactivation by alpha-2 macroglobulin, terrible word, and antithrombin, these rate constants depend on the levels of fibrinogen. Yeah. And if you look at the equations, there's nowhere is the level of fibrinogen found. So my question would be, how do you think that fibrinogen influences the rate constants of the inhibition? What is the mechanism behind it? Can you explain me this a little bit?
About the fibrinogen inhibit.
So it's not showing up in the equations themselves. The fibrinogen levels are sort of behind the scenes, pushing or pulling on the rate constants. How does that happen?
Yes, it actually shows in the capacity thrombin decay. I think it already calculates these changes into thrombin capacity decay. Yeah, but under this mechanism, I'm not very clear about it. So.
Okay. Well, I can try to explain why I think this is the case. It's because all these factors are competing for the active site of thrombin. So if there's more fibrinogen, then antithrombin has to wait maybe a little bit before it can enter the active site. So the more of one of the, so you have three competitors for the active site. Okay, so that's my. I just wanted to test your knowledge on that, and it's not a big deal that you didn't know exactly because that's hardcore biochemistry. But then I have, of course, I moved to figure 5 because this involves your thrombin dynamics measurements, and that is on page 45. And in this figure 5, you see differences. And I just wanted to go over the differences. But first, I want to draw your attention to panel E, 5E. And I think everybody, even without knowledge of all the factors, sees that there is not much difference. And I would say that you should see a difference, because if you go to table 2, that is on page 42, it's not significant, but you can still see that fibrinogen levels are quite a lot higher during the asexual parasitemia, and also at day 64. So my question is, if you see these differences in fibrinogen and you state that your thrombin decay capacity is dependent on fibrinogen levels, why are they all flat? You know, why are there no differences?
I think we have proved that fibrinogen in the table 2, fibrinogen didn't show any difference in the table 2. So it's the determinant of to calculate thrombin decay capacity. So I think it should be the same.
Okay.
Yeah.
So your statement is, if there's no statistical differences, then there is no difference.
No differences.
Okay, good. I'll leave it. I'll leave it like that. Then there is a microscopic elephant in the room. That question was not programmatic. We didn't discuss it, and that's the life cycle of your parasite. And there's not so much, or maybe one of my, but how do you link the findings you see to the life cycle of the parasite? Because I have been trying to wrap my hand around it. What is so special about the asexual parasitemia compared to the gametocytemia? What is the biologic difference between the two? And why is one so much more anticoagulant than the other?
I didn't catch the question.
Okay. Then I'll ask again. So you all the time during chapter 2, you're all the time comparing the life cycles. Because we have a baseline, and then the patients or the province get infected. I don't know who actually wants to do with this kind of clinical trial, who wants to participate there, but it happens. And then people get sick. Which is the state that they are the sickest?
Sick?
Yeah, which state the province feel most miserable? Which one is it of the phases that you see here in the...
The CHMI is a controlled human malaria infection, and we collecting 16 people to do this experiment.
Okay.
Yeah.
And these people, when are they, you have these 4 stages in your figure, what is the stage that they say, oh, I'm the most miserable?
Yeah, the baseline is our health state, right? Mm-hmm. And the D16 is correction after correction.
Yeah.
And the difficulty is asexual parasitemia and gametocytemia, I think.
These are the 2 phases. So these are the 2 phases where they where they feel more.
Asexual parasitemia, you can detect the blood. Yeah. If you take the blood, you will find there's no infected red blood cells in your circulation, and the gametocyte you will get infected parasited red blood cells in your circulation, and this this is different stages.
Yeah, because I was just trying to see which of the states you listed here, how it correlates with the clinical condition of the patient. But my time is over, and I saw the prorector already giving me the signal. So I want to thank you for your questions and for the discussion, and I give my word back to the prorector.
Thank you very much, Professor Koenen. The next opponent is not here, but present online. Professor De Maat. She is Professor of Hematology at the Erasmus Medical Center in Rotterdam. Professor.
Thank you, Mr. Prorector. I can hear you fine. So thank you for the invitation to participate in this committee today. We have some technical challenges, so you can hear me but not see me. So excuses for that. And of course, I would have preferred to be there in person, but I'm in Denmark right now, so that's a bit too far to come. So I read the thesis with much interest, and I'd like to congratulate you and your team with this thesis. So I would like to discuss with you chapter 3 on the abicavir use and the prothrombin conversion. And you describe in your introduction that it was previously found that the peak height and the ETP were increased in this group of patients. So I was wondering if there are other coagulation markers measured in this treatment, and what happened with them if you in the course of the infection. Do you have any information on other coagulation markers?
Dear esteemed opponent, thanks for your kind words and thanks for your question. Yes, as you say, we didn't show the thrombin generation test in this chapter 3 because other studies have already proved that the ETP was higher was higher. And if you want me to explore other indicators of thrombin coagulation, I would say you can test the cytokines like TNFR.
You haven't done any other tests yet.
Yeah, I didn't test these factors. Didn't test this. Yeah.
There's a lot more to be done. I was having some questions about some of the choices you made in designing the study. And the first is that your control group consists of healthy individuals, but they are much younger, and there are also much more women than in your patient group. You mentioned this in the discussion as a limitation, but I wonder why you choose this group as a control. Was it maybe a control group for another reason that it was suitable?
No, we don't want to choose so many women or men. That's not what I can decide. But maybe this people is we can get and yeah, that's my answer.
Okay, sometimes you have to do with what is available. But also in the other tables and figures, you compare the group using abicavir and compare them to the group not receiving this treatment. And I assume there's a reason why some patients receive one treatment and another group gets another treatment. So the doctor has to decide which treatment is given. So can you tell me what are the criteria of the doctors to say give one treatment or the other, and can that have an effect on your results?
Sorry, opponent, I didn't catch the question. Can you?
Okay, you compare, for example, in let's find a figure where you do it on page 65, figure 1. You compare the group with no ABC versus the group with ABC. But you didn't randomize people to this treatment, so there must be a reason why they are in one group or the other. Is it clinical parameters that decide which treatment a patient gets, and how does that affect your results?
Yes, we didn't find any difference in figure 1 of prothrombin conversion and prothrombin and antithrombin and F2M globulin. We didn't find any differences from here. But if you can see the figure, page 70, figure 4, we actually find in the panel of abacavir patients with treatment with abacavir and no abacavir, actually the total amount of prothrombin was significantly increased. That should be it can show the result of ETP was higher in this stage. In this.
You still don't really get my question. I mean, what the assignment of the treatment, but maybe you don't know anything about it.
No, we didn't. We didn't get any difference from this figure or from this result.
Okay, then I move on to another question, and it's on page 69. On the third line, it says that the total amount of prothrombin converted, it's 99 nanomolar in one group and 90 in the other group, and that it is significantly different. Is that a typing error? Can you see what I mean?
Sorry, can you explain? One.
You give the same. Okay. Does it help that he showed you?
Can you explain what the question? Can you explain the question? I didn't catch the question.
I just mean that you give the same mean level, I think, but you say it's highly significantly different. Is this a typing mistake? Okay, you probably don't know by heart.
No, I don't think it's a typo.
Okay. Let's move on to the next question. It's about page 70. You show there in all the figures a gray bar, which is the normal range. And then I can see that almost all of your values are within the normal range, and a few are out of it. Do you agree with me on that?
I can hear you. Yes.
Okay. And I was wondering if, since almost all levels are within the normal range, what does it mean then clinically if they are so normal? Can they have a real thrombotic effect if they are so normal?
You may give a short answer, please.
Platelet activity, I think, is not normal because you can see the total amount of prothrombin conversion and the maximum prothrombin gets higher in the APC treatment. Yes, and I think if you get treatment, VWF levels will be normal, because in other study, the ADMTS 13 activity was recovered, and I think that's okay.
Thank you very much for your answers, and I give the word back to the prorector.
Thank you very much, Professor Maat. The next opponent is Dr. Urbanus. He is Associate Professor of Thrombosis and Hemostasis at the University Medical Center in Utrecht, and he is affiliated with the Van Creveld Clinic also in Utrecht. Professor Urbanus.
Thank you, Mr. Prorector. Dear candidate, I would like to extend my congratulations to you for your wonderful thesis, which I read with great interest, and I would also like to include your supervisory team in those congratulations. I've read it with interest, mainly because it contains 2 chapters on my favorite subject, which has been my favorite subject since I started my career as a student of one of your supervisors. So for the past 20 years I've also studied antiphospholipid syndrome, and I was very happy to see that you also included some data on antiphospholipid syndrome here. So I was wondering, based on your results, would you consider the von Willebrand factor pathway a good therapeutic target in antiphospholipid syndrome?
Dear esteemed opponent, thanks for your kind words and thanks for your question. Yes, I think VWF can be a good therapy. A good goal of our therapy is if we fix the VWF function. Because VWF can help with thrombosis. If you see all of my thesis, VWF can induce the thrombosis in malaria and HIV. Of course, HIV, the people living with HIV have been treated with CART. And
if I may interrupt you, it's yes, of course, HIV and malaria, but I was specifically asking for antiphospholipid syndrome. So, do you think targeting von Willebrand factor would be a good idea?
Yeah, it's a good idea. Yeah, because VWF in thrombosis, VWF can act as a carrier of factor VIII. If VWF is dysfunction, it will be lack this carrier function, and it will be the coagulation cascade will be interrupted.
Will this then apply to all patients with antiphospholipid syndrome? Those with arterial thrombosis, those with venous thrombosis? What do you think?
Yeah, VWF is associated with VT venous thrombosis embolism, I think, and the past studies have been proved, and I think VWF is also associated with arterial thrombosis. Yeah, in APS patients, actually we have found APS patients. APS also related with these two thrombosis.
All right. So thank you very much. So let's go into the mechanisms behind this link between von Willebrand factor and antiphospholipid syndrome, as you suggest in your answer. So I read in your systematic review that there is data that suggests beta-2 glycoprotein 1 of the targets in antiphospholipid syndrome, is actually involved in two separate processes related to von Willebrand factor. One of them is inhibition of von Willebrand factor function, and the other one is inhibition of ADAMTS13. So which one do you think is most important in antiphospholipid syndrome?
In my opinion, it's the same important in inhibit the activity of VWF or inhibit the increase or recover the activity of ADM anti-13. It's the same. Yeah, and actually in many diseases, we also observed that VWF activity was increased, and also a dysfunction of ADMTS13. Yeah.
Did you test that ADAMTS13 dysfunction? Because I did not see that in your data.
In our assay, we didn't test ADMTS13. We didn't test it.
So how would you what would you expect to be the effect of dysfunctional ADAMTS13 in your studies?
I think you mean in APS patients? I think because APS patients have more thrombosis, so I think the function of ATMTS13 maybe decrease in the activity.
That's very interesting, because I know only of one disease in which ADAMTS13 activity really is decreased, and that is thrombotic thrombocytopenic purpura, which is a severe life-threatening autoimmune disorder associated with low ADAMTS13 levels. They experience microvascular thrombosis mostly. So do you also see that in your APS patients?
Can you repeat the question?
So if you have defective functioning of ADAMTS13, you know of a well-characterized disease in which that also occurs, and they have microvascular thrombosis. Do you also see that in APS?
Actually, VWF, the activity of VWF is associated with shear force. So the shear force is very high in the micro vessels, I think. So I think it's very related with thrombosis of microvascular thrombosis in the APS patients. I think, yes.
Thank you. That brings me to the next question, because I was intrigued by your mentioning of shear stress and von Willebrand factor. So you also mention unfolding of von Willebrand factor. So what is that, unfolded von Willebrand factor?
Actually, unfolded in von Willebrand factor is active von Willebrand factor. Unfold means it's A1 domain was exposed in the patient. Exposed, yeah. Because VWF has many forms. It have ultra-large form. If it's secreted from platelet, it's ultra-large form, and ultra-large form is also its unfold pattern. Yeah, unfold pattern. Yeah. And it will rapidly lift by EM to S13 and to the globular form, and this in this form, A1 domain will hide, and this is folded form. Yeah, and if the shear force is high, more than 1,000 per second, I think. Yeah, the globular form will be expanded and into the linear form. Linear form also unfolded form because it exposed its A1 domain. Yeah.
I interrupt here. We have to move on.
Yeah.
Thank you. I'll give the word back to the prorector.
Thank you, Professor Banes. The fifth and last opponent is Dr. Frauke Swieringa. She is a research project leader at Synapse Research Institute at Maastricht University. Dr. Swieringa.
Thank you. Dear candidate, for me as well, I would like to congratulate you on your hard work and your beautiful thesis. And I would very kindly like to congratulate your whole promotion team who have helped you make this happen. So thank you for your nice presentation in the beginning to give a summary of all your results. I as well read it with a great fascination. It's a story on the involvement of von Willebrand factor in coagulation processes under very diverse pathological conditions. So I have the honor to be the last one today to ask you questions. And I try to look a little bit at the question chat you've had before. But first I would like to start a little bit generally. So for me as a reader of your thesis, I think there are two big stars. It's von Willebrand factor and it's thrombin. So I was wondering, which one do you think is the most important, or which one is more deserving of the study? Is that von Willebrand factor or thrombin in these pathological conditions that you have looking at coagulation?
Dear esteemed opponent, thanks for your kind words and thanks for your question. As for the importance, I think they are both of them are important. But if you want me to measure which one first, I will measure the thrombin generation, because thrombin generation test have more parameters, and it reflects the speed of thrombin generation and the potential of thrombin generation. I would say thrombin generation.
I'm happy that you give that answer, because that helps me to continue with my questions. Because as you say, thrombin generation and then the thrombin generation assay is very important, specifically in your research. So I would like to elaborate a little bit on thrombin generation as a technique. So can you tell me, why do you think it is a good test, or why should we all measure thrombin generation?
Yes, because the first and important is that thrombin is an essential enzyme in the coagulation test. Without thrombin, we will not get the coagulation cascade. The coagulation cascade will be interrupted, and so it's a central enzyme. And the thrombin generation test, as I say, have give us many parameters and give us many information, of our thrombin generation.
And what can we then do with all these parameters? What information does it give us? What does it predict? What does it tell us?
Lag time of thrombin generation will give us the information that what time can we get thrombin generation, and thrombin ETP give us.
Let's say the parameter is different than normal. What information does it then give us? Is it predictive for certain diseases, or?
Yes, it's predictive. If we use normal pool from healthy individuals to build the normal range of thrombin generation parameters, and if it's exceeded or it's lower than the normal pool, I think it will get thrombotic events or bleeding events.
Okay, and if I then compare it to other coagulation tests, the standardly used in the clinic, in APTT or PT, what is then the benefit of using thrombin generation instead of the standard tests?
I would say our thrombin generation test will be accurate, because it can be simulated, and it can activated by a low levels of tissue factor. I remember it's 1 nanomolar. But other tests like prothrombin time or activated partial prothrombin time, we don't. I think the sensitivity of this test won't be so accurate.
Because they trigger much harder, so they are less sensitive, you think? Okay, I would agree. Then another small question, because then we have the thrombin generation, but you expanded further to thrombin dynamics. Could you also maybe speculate a little bit on what you think is the added value of thrombin dynamics when we already have this very sensitive thrombin generation assay? So what does thrombin dynamics bring extra?
Thrombin dynamics. Of course, thrombin dynamics also tell us many parameters like prothrombin conversion, the speed of prothrombin conversion, and thrombin inactivation by antithrombin and after corroding, and the thrombin decay capacity. This also can be activated by a lower concentration of tissue factor. So I think it's also very important, and it's same important with
I would agree. Yeah. So not only the forming of thrombin is important, but also the decay of thrombin.
Yeah.
Okay, then if I may, I would like to continue a little bit. It's a follow-up of the questions that we've had before, but my background is in platelet physiology and platelet pathophysiology. So I would like to go back to that a little bit. In chapter 2, and it has been discussed already in a few different ways, but I would like for you to explain to me the difference between the decrease that you see or the increase, sorry, that you see in the p-selectin levels and the decrease that you see in the platelet response to a stimulus. So the basal levels are increased, but when you try to trigger these platelets, they are less responsive. What do you think is happening there?
I think you mentioned table 1, right?
Mm-hmm. Oh, I think it's figure 1 mainly.
Table 1.
Oh, figure 2, yeah.
Figure 2? Yeah. Figure 2 can tell us that p-selectin
Ora est.
Mr. Shengshi Huang, the time for defending your thesis has passed, and the committee will now discuss the quality of your thesis, and in particular the quality of your defense. And I request that you and your company withdraw from this room and come back when we have finished our deliberations.
All rise, please.
gelopen.
Kindje huilen.
Manuscript. Hij moet vandaag nog teruglezen.
Please be seated.
Mr. Shengshi Huang. The degree committee here present has assessed the quality of your thesis and in particular the quality of your defense. And in view of this positive verdict and also taking into account your previous qualifications, the committee has decided to grant you the degree of doctor. And Professor ten Kate is authorized to confer upon you this academic distinction in accordance with Dutch university custom and law. And I invite now your supervisor, Professor ten Kate, to take the floor.
All rise, please.
Start with your promise. Do you promise to work in accordance with the principles of scientific integrity at all times, to be careful and honest, transparent, independent, and responsible?
Yes, I promise.
Good. By the authority vested in us by law, in conformity with the decision of the committee here present, I hereby confer upon you, Shengshi Huang, the degree of doctor and grant you all rights attached by custom and law. As evidence of this, I now present you with the degree certificate signed by the rector, the secretary, and the other members of the committee and affixed with the official seal of the university.
Please be seated.
Good Audacio, I hand over the virtual microphone to the
Dear Dr. Huang, congratulations with obtaining your PhD. Also on behalf of the complete promotion team, Professor ten Kate and Dr. Linkage, and of course congratulations to your friends and family in your home country. I think it's honest to say that your PhD period was with ups and downs. As you remember, I think you started on a very difficult subject, and after 1 year, both your supervisor and you wanted to stop the PhD. With an intermediate period with a second supervisor, I became your supervisor, together with Marissa and Romy. And I think you are very lucky with the Romy-Marissa team, as they are able to get any PhD students on track, independent of any difficulty, and up till now, with no failure. Apparently, that record still holds. I was happy to see that you regained your enthusiasm for science with this team and you started to work again very, very hard to obtaining your PhD degree and to finish your thesis. Still, it was not always easy, as after 4 years you had to go back to China, but there was no complete thesis that could be defended. In the meanwhile, you became a dad, started new positions in China. I can only imagine how tough that was for you. But during the last year, you were able to publish some very nice studies in peer-reviewed journals, and slowly the end came into sight. Still, it was difficult with the difference in time, the printing of the thesis, and all the other things. And I think the team again, together with you, did a great job. All the forms had to be completed, but you did it. Both Professor ten Kate and Marissa played a major role in this process, I think. I know you as a very quiet, almost shy person in the lab. You really had to find your way in the lab, and your Chinese PhD students proved to be of great help. But when something really needed to be done, forms to complete it in the lab or something else, you arrange it. Still, you are sometimes insecure and nervous, as you were also a bit, I think, today. Although you know all the subjects and everything very well. Finally, you've obtained your PhD title, something you've worked very hard for, and with great enthusiasm and perseverance. From today, you are Dr. Huang with all the rights and duties that come with this title. Chapeau.
Esteemed Dr. Huang, dear Shengshi, it's my pleasure to congratulate you with your doctorate, and I congratulate you also on behalf of Maastricht University. And I would like to share some impressions of the committee with you. We have seen and heard a clear summary of your thesis. And I think that also, because this is a layman presentation, I also think that many people as well here in this room as in the live stream have understood what you have done in the last couple of years. Your thesis is of good quality, and I have seen that a number of studies have been published in scientific literature. With respect to your defense, well, my first remark is that we have seen that the language barrier is significant, and it's a drawback for our discussions with you. And we regret that, but on the other hand, we understand that your knowledge and your scientific attitude is of good quality, and we are satisfied with your defense. And I would not only like to congratulate you with that result, but also your 3 supervisors. With the presentation today, the thesis, and also the number of publications that have appeared in scientific literature. And I congratulate you, Professor Hugo ten Kate, Dr. Bastelaat, and Dr. Marisa Ninivaji. I also congratulate your family, your partner, your wife, and your child, although I think the child is still very young. So congratulations also to your parents and other family members, and I congratulate also your colleagues here as well as in China and all the viewers and followers of the live stream. So congratulations. I would like to thank the members of both committees, as well the thesis assessment committee as this degree committee, for critically reading the manuscript and have a good scientific discussion and preparing your questions. So thank you very much for that. And in particular, I would like to thank the 2 external members, Professor de Maat and Professor Urbanus, for their contributions to this PhD, and Maastricht University appreciates your contributions. Thank you very much. Then I would like to have an organizational remark. We will, after this academic session, we will move to the hall of this building and take a picture with you in the middle and you as Paralymphus for the record, so that you can remember your PhD ceremony also on basis of a good photograph. Hereby I close this academic session.
All right, please.